Guys, we're back with a hard problem today, and this is a very interesting problem, and it's one of the most interesting problem I've seen in my entire life, because you see, like, in the comments are disabled and the submissions are restricted to Java as well, and the submissions are whatever it is restricted to Python as well. Like, it's a very tough problem. Like, people haven't solved it since, like, it's been like the last 12 hours, and there has been not a single submission on Java or Python across this. And I've also tried. You can see my submissions as well. So if you see my submissions, I have tried 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, say 20 times. Around 20 times I have tried this problem. Okay, and the highest test cases which I passed is 335 in Java, is 624 in Java, which is highest in the country right now for today's problem statement. But like, as you know, you have to pass all the test cases. So you can see that what I have done is I have solved it in C++, and the solution in C++ is accepted. There's some issue, I don't know, maybe there's some hidden tricks, I don't know, but it's a very interesting problem, and pretty sure that I'm going to explain it nicely so you guys will understand it. Okay, so today's don't get demotivated or something like that. So today's problem statement is about account merge. So it basically given a list of accounts of size n, where each element's accounts is the list of the strings. Okay, the first account in0 is a name, and the second are the rest of the emails. So our task is not to sort the names first. Our task is to arrange this in the sorted manner, and this is one of the most important questions of data structures, because this question focuses on disjoint set units. So if you are good in set theory, if you are good in mathematics and the disjoint sets and this data structure, it will be very easy for you. Also, you can see there's an accuracy of very less accuracy over here. Till now, the submissions are also very less. And today, we want to first analyze this problem. You can see there are some 4 accounts: John, Mary, and John. And now we have to sort them, and the output becomes John and their corresponding emails. Okay. So before that, let me explain the problem statement very quickly. Then I will explain the ++ implementation as well. So yeah, I'll just quickly present it. Yeah, thickness to black. Yeah. So like, before solving this problem, what we are going to first write over here is the name of the problem, right? So every time we solve, we have to mention the name of the problem for easier understanding. So say accounts merge is the name of the problem, right? So what basically this problem statement is, say for example, we are having some list of emails. Okay, so I will just quickly want to draw a list of emails. So this will be say a list of emails. Okay, so in this list we are going to put the names. So say for example, John. We are going to put another name, say John, and Raj, and John, Raj, John, Raj, and say Mary. Okay. So now carefully see one thing, that John is having set of emails. Okay. So j1@.com, j2@.com, j3@.com. So I can write j1@.com, j2@.com, j3@.com. Similarly, the emails for this particular job is j4@.com, and for Raj, what email IDs we have is r1 and r2@.com. So r1@.com, and for Raj we can also have r2@.com. For again, you can see John has appeared, and over here John has j1 and j5. So over here John has j1@.com and j5@.com. Say for example, take Raj. So Raj has r2 and r3. Okay, so over here Raj has r1 and r2, but again Raj has r2@.com, r3@.com, and Mary has m1@.com. So say Mary has m1@.com. So this will be our possible list of say emails. So what I can do is I'm just gonna take the color put yellow over here, and write it over here. This list, this particular list, okay, this, sorry, this is the names, okay, and this is the email IDs. Okay, so these are the email IDs and the list. Now I'm going to just give a numbering to this particular thing. So for example, let me just take a number. I'm just going to order it according to their order. So it will be 0, 1, 2, 3, 4, and 5. So before, like finally after doing this, we are going to make a disjoint set. So how we are going to see and analyze a disjoint set? Here comes the interesting part. So what I will quickly do is, I will put the corresponding indices and their corresponding email IDs in the sorted possible manner. So in disjoint set, disjoint set is a set where the elements calls the parents itself. Like the elements calls itself as the parent. Okay. So you can see there are five possible combinations. So I will write it like this as 0, 1, 2, 3, 4, 5. Okay, and I will just circle it, I made 5 sets. So these are individually calling themselves. Okay, these are individually calling themselves. Okay, so now next what we are going to do is, we have to understand that we have to make a relation out of this table, right? So let's make a relation. For table 0, what are the elements we have? So for table 0, the elements which we can have is J1, J2, and J3, right? The elements which we can get is J1, J2, and J3. Similarly, let's come to the second column, which is John 1. So in the second column, we can see is in 1, what we can get the elements as, only one element is there, which is J4. Okay. Now let's come to the third column, which is Raj. So which is the second element in the disjoint set. Raj has R1 and R2. Okay. We will quickly write over here in Raj column. We will quickly write over here as R1 and R2. And in case of the 3, which is again like you can see, 3 has J1 and J5. So what are we going to do? 3, we have already said that disjoint sets maintains a relationship with the parent. Okay, so for 3 you can write 3 J1 and J5 again, but you have to see J1 and J5. 3 J1. So J1 is present where? Before this, have you seen 3 somewhere? Yes, it is seen in the set 0, because J1 is present over here in the set 0. So obviously we have to make a relationship between J1 and the set 0, and this J5 will eventually be added to this particular set 0. So over here we have to add. I'll just take it as a different color as the elements which are maintaining relation, say J5. Okay. Now let's come back to 3. Let's come back to 3. So in 3, what you can see is there will be no elements now, because the relationship has been maintained. Let's come to 4. Okay, let's come to 4. 4, you can see R2 and R3 is there. Okay, in R1 there is an R2, so it is maintaining a relationship with the second one. So when it is maintaining a relationship with the second one, what we can do is we just have to link it to the second one. So I will again maintain a relationship with the second one, making it a different color. So what you can see in the second one, we are having an additional element which is R3. Okay. Similarly, from the disjoint set R5, what you can see in the fifth disjoint set, there is M1, which is not present in any other sets. So I will write like this, M1. Okay. So this is my final list. So before that, I'm going to make relationships. So you can see what relations I have drawn is 3 is having a relationship. 3 is having a relationship with 0. So I will write it over here as 3 is having a relationship with 0. 4 is having a relationship with 2. So 4 is having a relationship with 2. Okay. Now I'm going to erase 3 and 4. Yeah. So this is our final set. You can just write it over here as final. Okay. So this was the entire concept. So once this is done, we are going to make a final list. So in that final list, whatever we are going to do is it is going to be basically like J1. Okay, so we have to check J1 j1 @ J2 @com, and J3 @com, J4, J5. Sorry, J4 and J5 is not there. J3 is only there. And what we're going to do is we have to also see a J5. So we will just quickly we are going to just put the elements. So before putting the elements, I'm going to check. Yeah. So J1 0, J1 0, right? So I will write it over here as J1 is 0, J2 is also present in 0. Okay. J3 is also present in 0. Okay. And what else? There is a J4 1, but J5 is there. So what I'm going to do is J5 @com is present in 0, and then there is a J4 which is present in 1. Similarly, R1 R2 is there. R1 R2 is there, and R1 R2 is there. So what basically I've done a mistake with her. Just quickly check. This will be later on. Yeah. So J1, J2, J3, J4, R1, R2, then J5. Okay. Then R3, and then M. Okay. So in R1, what I'm going to write is 2. R2 it will be 2. J5 it is 3, and R3 is 4, and M is 5. So this is our final resulting list. So this will be the result which we have to do. Okay. So initially it was looking a bit hard, but when you visualize this problem statement with the help of I will write it over here using DSU or disjoint set. Okay. This is done using DSU or disjoint set. Now I'm going to go to the coding implementation. So I'm just going to quickly come to this C++. Okay, I have done this in def C++. Yeah. So what we are going to do today is first we are going to make a class disjoint set. Okay. So class disjoint set is doing nothing but basically it's of public class. So we'll just name it as public. And yeah, then we are going to take an array list, or you can say a vector over here in C++. So vector of parent vector and size. Okay. Now there will be a disjoint set constructor over here. So I'll just take the constructor disjoint set. I'll parameterize the constructor by passing a value. So over here n is being passed. I want to resize the parent vector to hold n+1 elements. So I will just write over here parent dot resize n+1. Okay, size dot resize n+1, 1. So we are doing resizing the vector size vector to hold n+1, all initialized to 1. Okay, so all initially the vector values are 1. Okay, in the table. So we are going to int I equals to 0, I less than equals to n, I plus 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 plus. Sorry. Parent of I is equals to I. So what is this doing? This is basically saying initializing each element's parents to be itself. Okay, which I already explained using those arrows and told you now that each set of the disjoint set is known as the parents of itself, right? So it has been explained over here. So disjoint set class is over. Now we are going to find the ultimate parent. So here we find the relationships. Find UPR, or the ultimate parent, UPR. We are going to pass a node. Over here we are going to check if the parent and the node is equals to node, then we will return the node, or else we will return parent node equals to find UPR of parent node, we're going to just give a find ER and then this if condition. Okay, now we are going to by union the size, so void union by size. Okay, int u, int v, int uu equals to find upr, which is the ultimate parent. Int uv equals to find upr of v, ultimate parent of v. If uv u equals to uv, then we will return. If the size is greater, if size of uu is greater than size of say uv, what we're going to do is parent of uv is equals to uu. Size of this particular, so over here I have to just take a curly brace, size of uu plus equals to size of uv. Okay, so the else is closed, then I can write the else. In the else block, what we can include, parent of uu is equals to uv, making uv as the parent. Then size of uv is equals to, is updated to size of uv. Okay, we are close 3 row theme. Yeah, now we are going to make the class solution. So class solution over here uses some you can see. We'll explain it quickly. Yeah. Combine, submit. So over here what we are doing is, in the class solution we are taking a vector string, okay, which is like the array list type, and then we are taking an unordered map to store the first occurrence of each email. Okay, then we are taking int n equals to accounts.size, which is the number of accounts. Disjoint set ds, initializing the disjoint set with n accounts. Okay, we are iterating through each of the accounts, then we are sizing, like we are iterating till the size of the current account. Then we in the map, what is the map? Okay, so map is basically used to, you can see map, if the email is not found in the map, it is added to the current index. Okay, over here it's done. Next, if the email is found the union current account index with the stored, it is passed to a ds union by size. So this was the function over here we have made. Okay, and then there's a vectors. Vectors are used to store the emails grouped by their parents, and the resultant vector to store the merged accounts. We are iterating through the map of emails, then we are iterating through each group of the emails, and then lastly we are collecting the non-empty groups into the resultant vector and returning the merged list. So yeah, so initially what we saw, like if we see today's problem, just for the last time, we have taken accounts merge as the names and the email IDs over here. Then we are using a disjoint set technique to sort this email IDs. What you can see is 0 to 5 are the elements, and these are the individual email IDs over here being arranged. Whenever we are finding a relation, first we found that 1, 2, 3, 4, and 5 are the entities, but whenever we saw that there is individually present, they are the parent of itself. So we are maintaining the relationship which I have drawn from, suppose some element is present suppose some element j5 and j1 is also present, so it is linked to the entity 0 because j1 is also present in 0. So similarly we have done, and for 4 also we have done, and all those things, because j4, you will see j4 is you will see j5 is 3, because whenever we are taking j5 as 3, it means that the j1 is linked, but j5 is also not linked, right? So j5 will be in the third position. So similarly we have done this. Okay, we have completed this problem. So I hope you like today's solution. Thanks.